Welcome viewers. In this video we'll see the solved problem in star delta transformation, converting star network into delta network into star network. The explanation for star delta transformation, the derivation available in previous video. The link is available in the description box. The viewers can see the explanation of star delta transformation. The derivation is available. In this video we'll see the problem. First we'll see the problem 1. Calculate the equivalent resistance between the terminal A and D for the circuit shown below. So this is the network is available. The circuit is available. This is the terminal is A, B, D and C. We need to find the resistance between A and D. These two terminals. Between the A and D we need to find the equivalent resistance. So the 5 resistors available, 12 ohm, 12 ohm, 4 ohm, this 8 ohm and 12 ohm. So we cannot find easily between A and D, there are resistors are connected. So we can go for star delta transformation. By that the circuit becomes simplified, then we can find the equivalent resistance between A and D. First we will consider this delta network, A, B, C, this delta network. We will convert this delta network into star network. So this terminal, after converting the equivalent, this terminal is A, this terminal is B and this terminal is C. So we can replace this delta by this star. Then how will you find the value? So the equal resistor, all resistors are equal mean R star, this value equal to R delta divided by 3. This formula is available. The delta is same. 12 voltage, 12 ohm for all the 3 resistors. So 12 by 3, 4 ohm. So this delta, the 12 voltage, the equivalent star voltage is, star resistor is 4 ohm. Now we can replace this delta by star, this in this diagram. You see that now this terminal ABC is replaced by the star. This is remaining terminal D. This delta is now replaced with the star. The course material available in the link drive. You can download the material using the drive. So after converting this delta into star, then now the circuit is simplified. How it is simplified? We need to resistance between A and D, only A and D. So we can simplify this. So this 4 ohm is available. So no need to bother about B and C because we need only A and D. So these two resistors are connected in series, 4 plus 8, 12 ohm. These two resistors are also connected in series, 4 plus 4, 8 ohm. Now this network is simplified as it is. We need a resistance between A and D, so we need to no need to bother about B and C. It is connected, directly connected. B and C is not. If you want to find B and C, at that time we need to concentrate. But now we need only A and D. So B and C not considered. So these two are connected in series. These two resistors are connected in series. Now it is simplified. Now what is the combination here? By seeing the diagram, we can easily identify these two are connected in parallel. That is connected in series with the 4 ohm. This 12 ohm and 8 ohms are connected in parallel. That resultant is connected in series with the 4 ohm. So we can go for the further simplification. So RAD, the resistance between A and D is nothing but 4 plus this combination, parallel combination, 12 into 8 divided by 12 plus 8. That is R1 R2 divided by R1 plus R2. If two resistors are connected in parallel, the formula is R1 into R2 divided by R1 plus R2. So 4 plus 12 into 8 is 96, 12 plus 8 is 20. So 4 plus 96 divided by 20 is 4.8. So 4 plus 4.8 is 8.8 ohm. The resistance between terminal A and D is 8.8 ohm. right? So in this problem we made one transformation. One delta is converted into star so that the circuit is simplified, then further simplified, then we calculated the resistance between A and D. Now we'll go to the second problem. Now we'll see the problem, second problem. Calculate the equivalent resistance between B and C for the circuit given below. So what is the B and C here? This is the terminal A, B and C. So we need to find the resistance between B and C. Right? So here one delta network is available. Inside one star network is available. So we cannot easily simplify. So what we can do, we can consider the star network. We'll convert into delta. So the star network available inside is converted into delta network so that the circuit becomes simplified. So what is the resistor available in star network? 1 ohm. All are 1 ohm. If all the resistors are equal, the formula is R delta equal to 3 times of R star. Right? If the star network all the resistors are equal, then the delta network R is R delta equal to 3 into R star. What is the resistor R? R star is 1 ohm. So 3 into 1, 3 ohm. So this star network is converted into delta network with the resistor value is 3 ohm. Now we can replace this star network with the delta network, equivalent delta network. So that diagram is available here. See this. Right? So this is the delta available outside. So now inside a star is now converted into delta with a 3 ohm. Now we can easily simplify this diagram, that is these two are connected in parallel. So connected in the between A and B, these two are connected at the same point. So these two are in parallel. Similarly these two are also parallel. Similarly these two are in parallel. Right? So how will you find the parallel resistor? R equivalent equal to R1 R2 divided by R1 plus R2. So all resistors are same. So 3 into 3 divided by 3 plus 3. So 6 by 9 is 1.5. So it is very easy. If both the resistors are equal, while parallel, it becomes half of the value. 3 become 1.5. If 10 ohm is connected, 10 ohms connected in parallel means the resultant will be 5 ohm. 10 divided by 2, 5 ohm. Similarly here 3 divided by 2, we got 1.5 ohm. Now see this diagram. Now it is further simplified. 1.5, 1.5. All resistors are 1.5. Now what is the question? We need to find the resistance between B and C. So we no need to consider A. Our aim is to find the resistance between B and C. What is the resistor connected between B and C? This 1.5 ohm. In another end, this 1.5 and 1.5 are connected in series, because now we are not considering A. We need only B and C. So in between B and C, this 1.5 ohm is connected, and other end these two are connected in series. So 1.5 plus 1.5, 3 ohm. Now these two are connected in parallel. This is one resistor, another resistor connected in parallel. So 1.5 and 3 are connected in parallel. Then how will you find the equivalent? R1 R2 divided by R1 plus R2. 1.5 into 3 divided by 1.5 plus 3. 1.5 plus 3, it is 4.5 divided by 4.5, it is 1 ohm. Right? So the resistance between B and C is 1 ohm. So in this problem we made one transformation. The star network available inside is converted into delta. After that the circuit become like this, then become parallel, then finding B and C, these two become series. So we can finally find the answer. Now we'll go to the third problem. So in the third problem, calculate the equivalent resistance across AB for the circuit shown below. What is AB here? Refer the diagram. So this is AB, this terminal is C. So we need to find the resistance between this A and B. So this is one delta network. So inside one more delta is available, and apart from another 3 resistors also connected. So it is not easy to solve this not easy to go for any combination, series or parallel. All are interconnected. So we can do this, we can convert this star network into delta. So by using this, right, first we are going, the delta available inside will be converted into star. So that the diagram is available here. The inside star delta is converted into star network. So this value is 6 ohm. What is the star value? R star equal to R delta divided by 3. If all resistors are equal, this is the formula. So 6 by 3, 2 ohm. So the R star value, star network is 2 ohm. Right? So the inside delta network with 6 ohm now replaced with star network with the 2 ohm resistor. Now we'll see the diagram. See this. So this delta network with 6 ohm now converted into star network with 2 ohm. Now it is the circuit is now simplified. How it is simplified? These two are connected in series. These two are connected in series. These two are connected in series. So it is nothing but 2 plus 2, 4. Now it is further simplified. So the diagram is available here. This 4 ohm, 4 ohm, 4 ohm. Again, it is not possible to go for any further simplification. So what we can do? The star network available inside will convert into delta. The star network available with 4 ohm will go for convert this star network into delta. Now see this. So this is the star network available inside with 4 ohm that can be converted into delta. What is the delta value? R delta equal to 3 into R star. So 3 into 4 is 12 ohm. So the resistance of the delta network is 12 ohm. So the star network with resistor 4 ohm now converted into delta network with resistor 12. Now we can redraw this diagram. See this, the inside star now converted into delta with 12 ohm. Now what is the further simplification? We can easily see that this 4 ohm connected between A and B. This 12 ohm also connected between A and B. That is, these two are in parallel. Similarly, these two are in parallel, these two are in parallel. How will you find the equivalent resistance? R1, R2 divided by R1 plus R2. All values are equal, 4 and 12 only. So 4 into 12 divided by 4 plus 12. So that is 48 divided by 16. That is 3 ohm. The equivalent value is 3 ohm. Right? So these two as well as these two now simplified to 3 ohm. The diagram is available here. 3 ohm, 3 ohm and 3 ohm. Now what is the resistance we need? We need only the resistance across A and B. What is the resistance connected between A and B? This 3 ohm is connected. But other end is another 2 resistors available. We no need to bother about this value because we need the terminal A and B, resistance between A and B only. So that other end, these two are connected in series. So that is 6 ohm. Right? So in between A and B, this 3 ohm is connected, one resistor. These two are connected in series, that is connected in parallel with 3 ohm. 3 plus 3, 6. Now these two are connected in parallel. By seeing the diagram, you can easily see that connected in parallel. Then how will you find RAB? R1, R2 divided by R1 plus R2. 3 into 8 divided by 3 into 6 divided by 3 plus 6. 18 by 9, it is 2 ohm. The resistance between A and B is 2 ohm. So in this video, we discussed the star delta transformation. We solved the 3 different problems. The star delta transformation, the derivation available in the video. The link is available in description box. And also the course material for the same problem available in the drive. You can download the course material also. Thank you.